Okay, today we're working on 4.2a, and our goal is I can write coterminal angles. So we've worked with word questions, but now we're going back to the pure math and actually looking at that unit circle again. So coterminal angles. So far, we've only talked about um, theta being between 0 and 180, okay? But now we're going to define angles in standard position for any value of theta. Okay, so any value. So let's talk what standard position. Well, let our point px be a point on the unit circle with center O that has coordinates 0, 0, and again radius of 1. So we have the unit circle again. If that point P starts at 1, 0, the rotation of P from A forms theta. So that is the formal definition of what standard position is. Now, fine, that's the formal definition of it, but what does it really look like to us? Okay, so we have a few different things going on here. Okay, so angle theta is in standard form when OA is the initial arm and OP the terminal arm. So I have two axes here, and what they're talking about, if I take the point A, which is 1, 0, and I'm just going to clone it because I'm going to want it for over here as well. So I have this point, okay, and we also know that we have a point on the other side because you've been working with this, and it's going to have the coordinates, and I don't have the coordinate there. It's okay, I'm not going to worry about it. We have the other coordinate over here, which would be -1, 0. Okay, and it exists over on this side, and the reason we have that is the radius of our unit circle is 1 unit. Okay, and they're saying that we have angle theta is in standard position when OA, and O is the center of our circle. So here's our O, and it's at 0, 0. I don't think I need to put that. Okay, and I'm going to again put it over on this side as well. And it starts when the initial arm is located here. So this is my starting point. It's my starting point whether I'm going to go counterclockwise or clockwise. So that's my initial arm. And theta is defined from starting there and creating a theta. Okay? And where it stops, we call it a terminal arm. So let's create a terminal arm. And it doesn't really matter where I put it. I can put one here. I could put one for this one over here. So those are going to be my terminal arms. And again, we'll just bring it up and label it. So that's going to be our terminal arm. So they're saying that theta is created when point P, X, is on the unit circle. So imagine the unit circle here. I don't want to put it there because it really clutters the picture even more. And what happens is as we are going around that circle, starting at the initial arm and going and stopping at the terminal arm, that is what we define as theta. Okay, so theta is located from the initial arm and stops at the terminal arm. And where's our theta? We'll clone our theta. So this is theta. Okay, now when we go counterclockwise from our initial arm to our terminal arm, we say that theta is positive. So in other words, theta is greater than 1. Now we can also go counterclockwise because we could take the initial arm and we could go the opposite direction As long as I'm starting at OA and go this way, and what we create is a theta as well that's in standard position. However, what's happening here is now theta, we define it as being a negative value. So when I go counterclockwise, it is positive. When I go clockwise, it is negative. Okay, so just some defining things there for us. All right, so when we're talking about coterminal angles, two or more angles in standard position are coterminal when the position of that P, this P, is in the same is the same for each angle. Okay, so the position of P is the same. Okay, so if they're in standard position and we stop, that is where those are called coterminal angles. So what we have here, when an angle has a measure of theta degrees, then the measure of any coterminal angle is, you can actually come up with a little formula. Now, I'll be perfectly honest, I don't use a formula for mine, and it looks like I have something hiding behind here. There it is. So, and I have here regardless of the number of rotations. So far you're thinking, okay, I can go, around, once, and that's 360 degrees. But you know what? You could go around and around and around. So what I'm going to do, first of all, is I'm going to create my terminal arm here. And I'm going to tell you that this theta here, I'm saying is 50 degrees. I'm just going to switch to my writing pen. So this is 50 degrees. So that location of P is here on this diagram and on this diagram as well. Okay, and we know if I go this way, it is 50 degrees. But look what happens. I could start here. I could go around once, completely around once, and then stop. And this would be a coterminal angle. What would the value of this angle be? Well, obviously it's going to be the 50 degrees that we had, but I went 360 degrees one time, and I'm adding another 50. So what I end up having is 50 and 410 are coterminal angles. Now, I can go the other direction as well, and let's try that. So now I'm going to have a negative value. I could stop here, but let's keep going around and around, and now we'll stop. Okay, now you see why I didn't put a unit circle on there. It would get way too messy. So what's going on here? So I've made one complete rotation. And how many more complete rotations have we made here? So we've got 1, 2, and then this last little bit here. And I'll just switch that last little bit so you can see. You can see what I'm talking about. Okay, so this is a coterminal angle too because I stopped P in the same place. So we've gone 360, another 360. So we have 360, and we've gone around the circle 2 times. And actually 2 times, and remember going in the opposite direction, so it's going to be negative. And then how do I get this last one? Well, this last one is more than 50, so it's going to be plus negative 360 plus 50. Okay, so negative 360 plus 50. Okay, and so that would then give us our blue amount. Okay, so all the way around would be 360, but we're going to take away 50. So we end up with this being negative 720, and this would come out to being negative 310 for a grand total of negative, and sorry, that's in your way, negative 1030 degrees. Okay, now you're saying, like, who would go around that many times? Well, you'd be surprised. Students love to go around that many times, especially on a test. Okay, so what we found here is that 50, 410, and negative 1030 degrees are considered coterminal angles. They start with their initial arm on OA, and if they go clockwise, it's negative. If we go counterclockwise, we end up with a positive. Okay, so let's take a look at what we're supposed to do with this. Okay, so we have, for each angle, draw theta in standard position and determine two other coterminal angles. Okay, so we have theta is 120. Okay, so I'm supposed to draw it in standard position. So the first thing I'm going to do is I'm going to create two axes. One, two, 120. Well, this is 0. This is 90. This is 180. So that means that 120 would be in this position here. And for this one, I think we will put the unit circle on top of it. And I'll just have to move it to the right location. Okay, so that's where it stops, and that is 120 degrees. So from here to here is 120 degrees. So determine, so we've drawn it. Now you don't have to measure it exactly, but you definitely have to have it in the right quadrant. Now we could actually find the coordinates of P here, but we're going to do that on the question down below, so we'll leave it alone for now. So determine two other coterminal angles. Well, I could have a theta 1 that is 360 plus the 120. And if we do that, we end up with 480. Okay. There's infinite possibilities here. We could go around that circle if we wanted to keep positive. We could go around 4 times. So 4 times 360 plus 120. Okay, we're checking out my mental math here now. So 0, 4, 2, 14 plus 120. I'm sure that's how you calculate it in your head too. So 1560 degrees. Okay, so as I said, you can choose whatever you want. And let's do the next one. And the next one I'll change to blue. So after I draw my coordinates. Okay, so I again have my axes. And this time I have, and that doesn't look very straight, and this time I have theta is negative 120. So that means I'm going clockwise. So if I look at that, 0, negative 90, negative 180. So I'm looking at it being located in the third quadrant. And I'm just going to pause the video. Actually, I'm going to start a new video and finish these two questions up for you.